Hi dear students, welcome back to BS Academy. In this video we are going to discuss the second case of the concave mirror. Second case of the image formation of the concave mirror. See, for this we are drawing the concave mirror. So this is the concave mirror and this is the faded part of the concave mirror. We know this point is called as pole and this point is called as center of curvature, and the line which is joining or the line which passes through the center of curvature and the pole is called as principal axis, and this point is called as principal focus. We know all those things, right? In the first case we discussed that when the object is placed at infinite distance where the image formed. So that is what we discussed in the first case. Now see, in second case what we are going to do is, see, instead of placing the object in infinite distance, we are going to place the object just beyond the center of curvature. So it means what, students? We are changing the position of the object. Okay, so we are going to find the different position of the image by changing the different positions of the object. So previously we placed the object at infinite, no? Now we are going to place the object just beyond the center of curvature. Okay, so imagine that we are placing the object over here. So position of the object is represented by the upward arrow mark. So this is object. We can represent it as AB. Okay, right. Now see what will happen. The rays will emerge from the object, right? So consider the ray which is emerging from the object. So one of the incident ray is moving like this. It means this incident ray is parallel to the principal axis. So we know what happens when the incident ray is parallel to the principal axis. According to the first rule, when the incident ray is parallel to the principal axis, the reflected ray should passes through the focus. Is it not? Right? So this is the reflected ray. This is the reflected ray. Is it clear, children? Be clear about the light rays, then only we can able to draw the diagrams properly. So see, this is the incident ray and it is parallel to the principal axis. Therefore what will happen when it is reflected? The reflected ray should passes through the principal focus. That is what the first rule. So we are applying the first rule. Okay. Now see, we are going to apply the second rule now. What is the second rule? When the incident ray is passing through the focus. Second rule is just opposite to the first rule, no? So see, this is one of the incident ray. See, this incident ray is passing through the focus. So if this is the incident ray, what is happening? See, this incident ray is passing through the focus. So according to the second rule, when the incident ray is passing through the focus, then after it gets reflected, the reflected ray should becomes parallel to the principal axis. Okay, so this is the second rule. No, what is the first rule? When the incident ray is parallel to the principal axis, then the reflected ray should passes through the focus. Right? And we are applying the second rule. See, the incident ray is passing through the focus. Therefore what happens? The reflected ray becomes parallel to the principal axis. See, this is the reflected ray. So this reflected ray, it becomes parallel to the principal axis. So that is the second rule. So we are in the second case, we are applying both the rules. First rule and the second rule. We can apply any two rules, okay, to find the position of the image. Now see what I told you before. This is one of the reflected ray and this is another reflected ray, and the point where the two reflected rays meet is the point where the image is formed. Is it clear, students? Right? So this is one of the reflected ray. This is another reflected ray and these two reflected rays are meeting at this particular point, and we can draw the perpendicular line from the principal axis to this point. Right? So we can draw the downward arrow mark to this point where the reflected rays are meeting. So this is called as the position of the image. So we can represent it as A dash B dash. We can represent it as A dash B dash. So this is nothing but what? Image. Is it clear, children? See what happens? We placed the object beyond C. So the incident ray emerges from the object. One of the incident rays is parallel to the principal axis. Therefore the reflected ray passes through the focus. And see, the another incident ray is emerging from the object, but it is passing through the focus, and after reflection it becomes parallel to the principal axis. And what we are doing, we are finding out the point where the two reflected rays are meeting. So this is the point where the two reflected rays are meeting. So this is the point where the image is formed. So we have to draw the perpendicular line to this particular point to draw the position of the image by representing it as the downward arrow mark. Okay. So this is the object and this is the image. Okay. Now see, we can write the position of the object. What is the position of the object? The object is placed beyond C. See, the object is placed beyond the center of curvature, that is beyond C. And what is the position of the image? See, the image is formed between C and F. What is C? Center of curvature. What is F? Principal focus. So see, the image is formed between C and F, that is between center of curvature and the principal focus, right? So we can write the position of the image as between C and F. Okay. And what is the nature of the image? What happens, students, when the screen is placed over here in this particular point? What happens? We can able to see the image. We can able to see the image over here. For example, see, if we have placed the candle over here like this, if the candle is acting as the, you can imagine the candle flame as the object, then we can able to obtain the image over here. So here you will obtain the image like this. The flame of the candle will be obtained on the screen like this if you place a screen over here. So it means what? The image is obtained on the screen. So if the image is obtained on the screen, that image is called as real image. And see, here the image is the inverted image. So we will obtain the inverted position of the flame. So therefore the nature of the image is real and inverted. What will be the size of the image? See, compare the size of the arrow mark, the upward arrow mark, and here it is downward arrow mark. See, it will be very small, somewhat small when compared to the height of the object. So the size of the image will be diminished. What will be the size of the image? It is diminished. Is it clear, students? So this is about the second case of the image formation of the concave mirror. Is it clear? See, once again, the position of the object is beyond C. Okay. So we are applying the first rule. So when the ray is parallel, it passes through the focus. And we are applying the second rule. When the ray passes through the focus, the reflected ray becomes parallel to the principal axis. Then we are finding out the point where the two reflected rays are meeting, and that is the point where the image is obtained. So it means the position of the image is between C and F. It means whenever the object is placed beyond C, the image will be formed between C and F. So the position of the image is between C and F. And nature of the image is real and inverted. It means it can be obtained on the screen and it will be inverted. Okay, children, right. The size of the image will be diminished. So size of the image is somewhat smaller when compared to the size of the object. So be clear about the second case of the image.